Hello, everyone. Let me ask you something. If I give you a choice right now, which snack would you take? A slice of a fruit or a vegetable, or a sweet? I would imagine many of you would choose some sweet, and that's completely normal. Our brains evolved to seek immediate reward. Sweetness once meant survival. But what if I told you that regularly choosing the sweet increases the risk of metabolic and heart diseases and shortens lifespan? Now, who is still choosing it? Interesting, right? Even when we know the consequences, we don't always change our decision. But have you ever wondered if you are actually the one making that decision? As you may already know, our intestines are home to the entire ecosystem, trillions of microorganisms called the gut microbiota. These tiny microbes not only help us to digest the food, but also constantly communicate with our brain. And in this way, they may also be casting their vote, influencing our food choices. It has been established that continuous consumption of highly rewarding, highly caloric foods alters gut microbiota composition. However, it also changes brain functioning. Over time, eating might become increasingly difficult to control, and they persist despite negative consequences, what we scientifically call compulsive. Eventually, this can lead to the development of food addiction, which we now know induces similar changes in the brain as other types of addictions. So all of this led me to an exciting question. How much control those tiny microbes actually have over what we eat? And could they be driving the development of food addiction? And this is exactly what I did in my dissertation. So my first goal was to identify people with and without food addiction. For that, together with colleagues, we selected a general population of people of varied age, sex, and body mass index, and we applied 35-item questionnaire, which is designed to evaluate food addiction in humans. Some of the questions from that questionnaire might be more relatable than we would like to admit. For instance, have you ever drove to the supermarket to buy the snack that you craved, even though you had healthy alternatives at home? Or maybe you started eating something and realized you ate far more than intended, or continued eating even though you were already full, or to the point you were physically ill. And have you ever tried to cut down, to stop eating some foods, but felt irritable, nervous, and sad, and eventually relapsed just to feel better? These are not simply questions about enjoying the food. They reflect enhanced motivation, compulsive behavior, and relapse, core features of food addiction. So using this approach, we have found that around 10% of people had food addiction. Then we analyzed the gut microbiota composition of those people, and we indeed found some changes in those that had food addiction. Just to give you a bit of a glimpse into those results, we have a volcano plot, a little bit different from what we see previously. Each tiny bubble here represents each bacterial genera or species. Those bubbles that are above the threshold, which is the horizontal line, are considered to be significantly different in people that have food addiction compared for healthy individuals. So those bacteria that you can see on the right are the ones that were significantly increased in people with food addiction, meaning that they are most likely non-beneficial ones, while the ones on the left were significantly decreased. So what we did then, the issue is that when we work with human studies, there is so much we can actually do with that. And because of that, I shifted my focus to one of the most widely used experimental models, which was mice. And my main goal here was to explore whether mice and humans with food addiction have similar microbiota profile. To do so, I first needed to develop food addiction in mice. And for that, I used special boxes with levers called operant chambers. The principle is very simple. Mouse has to press the lever to receive the chocolate flavored pellet. However, food addiction does not develop in the day. It requires 5 months for gradually developing compulsive behavior. When we started to develop this protocol together with colleagues, one finding became immediately clear. Mice do not develop addiction towards regular chew. It emerged only when highly palatable chocolate-flavored pellets were used. And this actually resembles what we see in humans. Food addiction develops only towards highly caloric, highly rewarding foods, like a chocolate bar. I mean, who has ever heard of a carrot addiction, right? So the thing is that we created the environment for those mice to develop food addiction, but the question remained whether they actually developed the behavior. And for that, I used multiple behavioral tests, one of which evaluated their motivation. In this test, the value of reward increases, meaning that mouse has to press 1, then 5, 16, and more times to receive a single pellet. Those that don't have food addiction usually stops pressing after 200 or 400 times. But how many times do you think a food-addicted mice would press? Indeed, those mice start pressing the lever like crazy, and they can press 600 or even 800 times. And when you enter the room, you can hear the constant clicking of the levers. As you may remember from the human study, relapse is another feature of food addiction. So I tested that in mice using associative learning test. In this test, I rely on the fact that mice were able to associate specific cue light with chocolate flavor pellet delivery, since that light turns on when each pellet is being delivered those 5 months. However, what I did in this experiment, I turned off the light and pellet delivery. And as expected, mice stopped pressing the lever because it's of no use anymore. And this reflects the abstinence period. However, the interesting thing happens when we turn on the light again, but not the pellet delivery. Those that have food addiction immediately starts pressing the lever again and persist on pressing it, even though no pellets are being delivered. And this closely reflects what we see in humans with drug addiction, that relapse can be triggered simply by returning to places, environments, and social situations that were previously associated with drug use. So altogether, these behavioral tests, along with the ones that I didn't have time to explain to you today, allowed me to evaluate food addiction in mice. And what I found that around 20% of mice in my study developed food addiction. Then I explored the gut microbiota composition of those mice and indeed found similar changes as I saw in humans. One of the most striking similarities between both mice and humans that had food addiction was that one bacterial species called 𝗏𝗏 was significantly decreased. And this raised an exciting question. What would happen if I give mice 𝗏𝗏 as potential probiotic or food that supports its growth as potential prebiotic? Could this prevent the development of food addiction? And indeed, both 𝗏𝗏 and prebiotics significantly decreased the percentage of food-addicted mice, which reached close to 0, and decreased not only motivation, but also compulsive behavior. These exciting results encourage us to patent the prebiotics that we used as potential preventive measure against food addiction. And here today, you got a glimpse into this novel approach that might one day help to silence those eating modes coming from our gut, so that next time you choose between the vegetable and a fruit or a sweet, the choice is really yours. Thank you.
Thank you so much. Give it up for Solveiga.
Wow. Thank you very much.